Okay, so this interview is about you. So tell us a bit about yourself. So who are you? Why are you in China? What the fuck?
Morning, ladies. Today we are taking a look at the Zeal 8-bit computer, or, well, we talk about it. I did an interview with Omar, aka Zeal 8-bit computer, on YouTube, and he's the guy who designed this machine and programmed the OS and all the stuff that's on there. So he's an interesting guy. He's living in China right now, and I did an interview, took about an hour, and yeah, we are talking about live computers and everything pretty much. So stick around if you want to know why this is called the Zeal 8-bit computer, why he did things the way he did. And there will be a part three in which we will actually go and set up a development environment so that you can follow along and write software for this machine. This is an Z80 based machine, and yeah, it's pretty interesting. So enjoy the interview.
This video is kindly sponsored by the Black Swan. The Black Swan offers business coaching to business owners and helps them to create a thriving business that runs without them. For more infos on what the Black Swan offers, please check out the link in the description.
Hi, first of all.
Hello.
Thanks again for sending the machine and this shirt.
My pleasure.
I'm wearing the shirt, you see.
Yeah, fits you very well. Might be a bit too big.
Yeah, it's a bit spacey, but well, it's okay.
You know, Chinese size is very hard to decide.
Okay. Okay, so this interview is about you. So tell us a bit about yourself. So who are you? Why are you in China? What the fuck?
Yeah. So here it's 10 p.m. now, I think. Yeah.
Okay.
So my name is Omar, and I'm French. I'm currently working in China, in Shanghai.
Okay.
And so I'm an embedded software developer. And I graduated in France in Paris 7 University of Paris 7. I have a master in computer science. And what can I say more? So I started learning Chinese when I was in France, when I was at university. I had some spare time after my courses.
Of course.
I went to like in the daytime, like I was going to the courses, and then after the courses, I just go to the library. I was doing my projects. I still had some time after finishing. So I just took some books about Chinese and I started learning Chinese. I was very interested in the culture and in the language, and I really like learning languages. So I really liked it. Honestly, it's a language I really like. I still like, of course. And so when I had the opportunity to come here to work, I just say yes. And I've been.
How did that happen? Did you get a job offer in China, or did you move with a French company to China, or what's the deal there?
So when I started learning computer science, when I started learning Chinese, it was in 2013. And from 2013 to 2020, when I moved to China, I already came to China multiple times for traveling.
Okay.
So I was already familiar with China. I went to a lot of cities. And so in 2020, I got an offer from a company here, an international company, but who is based in Shanghai. So I got an offer. So I just left my job in France and I came to China.
Okay.
During the COVID pandemic. So it was quite a challenge. It was quite a challenge.
Best time.
Yeah, exactly.
But did you worked in France for in the same job, right? Or a comparable job?
Yeah, I worked in France, but I was working on critical systems. I was writing BSPs for automotive before.
Okay.
And so it was also embedded systems, but it was more BSPs with SoCs, ARM SoCs mainly. And then here I work more with MCUs, RISC-V MCUs. So it's on a lower level, I would say. It's still embedded software engineer, but it's different. It's more IoT related.
What was your first machine? Your first real computer?
my own computer. So I used to play with my father's computer, who it was a Windows 95 one, I think.
Oh,
Yeah,
okay.
I'm not that old.
A Windows
Yeah,
machine.
it was already like an x86. So
Okay. How old are you?
29.
Oh, okay. You're okay. Yeah, I can't hold it against you. So Windows 95 is okay.
So yeah, my own computer, my first computer was a laptop. It was a Dell Inspiron 6000, I think. So it was something already very modern.
Okay.
And I do recall my dad had a very old MS-DOS laptop. It was a Toshiba. I don't recall, but I think the CPU was a 16-bit Intel CPU.
Mm-hmm.
I don't recall exactly which one. But I could not use it because like it was all command line, and at that time I did not understand those things.
Okay. And how did you get to be interested in retro computers, or why did you do an 8-bit machine? I mean, you could, I think,
Yeah,
do something else.
Yeah, it's a bit weird. Actually, when I was young, I found it very interesting that sometimes you have some keyboards, what I called keyboards back then, that had computers inside. It was computers that you could plug to the TV and you had a computer. I don't know where I saw that actually, but I recall one day my uncle came home and he had one of them, like it was a keyboard and it was red. And I think now I know it's named Alice. So it was a French, Alice, yeah. So it's a French brand. And so you just plug it to the TV and there was the system, you could type things. But of course, I did not know BASIC back then. But I was still very interested in this. And since then, it never left me. Like I was always thinking about it. And then later, I learned that it was an 8-bit computer. And so at university, we were always learning about CPUs, about like, very theoretical, you know. And the lowest level thing we did is we designed the CPU with logic gates.
Okay.
It was on a computer. It was in Logisim, so it's still it's not real hardware. It's just like virtual.
Yeah.
And I always wanted to understand how it worked underneath. Like I asked my teachers, like, okay, but if you press a key on the keyboard, how does it trigger like a character on screen? How does that happen? It's like, oh yeah, it's too low level. It's okay. You don't need to understand. Like, but how does it work? And it's like, yeah, there is an interrupt. Okay, but what does the interrupt do? And still, I know it's like this. It's still very high level for me.
Okay.
And so in my daily work, I write some device drivers, but I don't work on the hardware level. Like I plug some I2C devices, SPI devices, but I don't work with CPUs, like CPU bus, address bus, data bus. So I was very interested in this. And I think an 8-bit computer is the best way to learn about this.
Okay. Cool. So what was your initial idea of doing the Zeal 8-bit computer?
First, it was about learning, I would say. Actually, the project started with the FPGA. So I learned by myself Verilog. Because back then, like at university, we did not learn VHDL or Verilog. So I learned by myself and I was very interested in. And I was able to make a very small display, very small, very simple display that displayed like characters. And I was like, okay, but how can I control this? And the easiest way was to make an 8-bit computer to communicate with it.
Okay.
And then I was looking for one online. And the thing is, all the 8-bit computers that I saw are either just single board computers, which run CP/M. I think that's the simplest solution, you know, like you just make an 8-bit computer, you put a Z80, you put CP/M, and that's it, it's finished. Compact flash, and that's it. Or other computers are also 8-bit, but they're not using any video chip. They have a MCUs, for example. Like ESP32, they have a 280 megahertz CPU to generate video output. It works, but it's way more powerful than the Z80, and the Z80 has, what's the point of the Z80? You know, so I was like in between. It was too extreme. Either you have nothing, just UART and CP/M, either you have like an MCU that is more powerful than the whole board, so why bothering with the Z80? So I came up with the 8-bit computer. Like I wanted to make not only a computer, but a whole ecosystem, which is why you will find Zeal bootloader, Zeal emulator, Zeal 8-bit OS, assembler. Like I did everything, like the assembler, the text editor, all the extension boards and everything. I wanted to make a whole ecosystem.
Yeah, that's crazy. I saw that and I watched your videos when you started, I think, maybe it was not the start, but the middle of you working on the Zeal 8-bit computer, and I was fascinated by the idea of creating your own computer and just doing that. And I also studied computer science, and I also learned about CPUs and stuff like that. But at some point, I was always a software guy, so I understand how this works internally, mostly to a point. But the lowest I went down was assembly language and machine language at some point. And yeah, doing that and creating your own computer is something that fascinates me. And there are actually two very good books. I don't know if you read them. I have them somewhere. This Code. That's from the guy who worked at Microsoft, and I think he invented C#. I'm not sure. Charles Petzold. He's very, very well known in the Windows community. He wrote, I don't know, hundreds of books, I guess, what feels like. And he describes what you described in terms of how to build a computer from logic gates. And then there's the elements of computing systems, which is actually a course taught in university, and the same approach. Also creating a virtual machine from logic gates to Tetris. So that is pretty much what you were looking for. How do you translate keyboard strokes to a machine? So these books are what I'm interested in and what I try to teach my 10-year-old son. He's, of course, a bit too young for that. But I want to interest him in how machines work, and especially in the dawn of AI. I call that the John Connor experience or John Connor course. Like in Terminator, the guy who fought the AI. I want my son to know how this works so that he can, if it's necessary, take measures against AI and stuff like that, and knows how machines work on the ground level and not just as a user in Windows or stuff like that. Yeah, maybe I'm too extreme for that, but yeah.
No, actually, the thing is, when I was at university, we had a course about compilers, and I loved it, and I still like compilers, writing some small compilers. And actually, I think like if you understand how compilers work, no matter or how the computer works, or how to write assembly language in general, it makes you a better programmer in any language, and even in JavaScript. Even in JavaScript, it makes you a better programmer because you understand what will be generated or what will happen behind. Yeah, right. And so I really like this low level things of computers. So you always learn things. Even if you are a Python programmer, you will learn a lot by learning more about CPUs and compilers and those low level stuff.
Definitely. I learned a lot from the Java virtual machine. I wrote the first German book about Java when it was still called Oak. And I came from C and C++, and then I saw Java or Oak back then. And I thought, this is the next level for programming, because you have garbage collection. You don't have to do your own memory management, stuff like that. That will revolutionize how things work. And yes, it's slow now, but machines are getting faster, and they will invent faster virtual machines and stuff like that. And I've first understood from the guys at Sun Microsystems and the design of the libraries and stuff like that, how good programming works. So I was a programmer already and a developer, and I did project management and stuff like that, and had huge projects as an architect. But that was my moment when I understood, okay, that's how programming really works, and how you do architecture on systems, and how you design libraries, and not just putting code out, but thinking about it and patterns and stuff like that. Yeah, it was a whole new world for me. It was amazing. I remember that time, and it was really like 3 years of straight learning, and such a curve. And when I go out today and I see JavaScript programmers and they just copy code from Google or stuff like that, I'm sitting there holding my head. They don't even know what they're doing. It's like monkeys with machine guns. It's really dangerous.
It's the same with ChatGPT now. People just prompt things, copy paste, and try to make it work. But actually, despite the hate, I would say, that Java gets, Java's not JavaScript, Java. Java is a very good language if you want to learn about programming in general. Like at university, we started with Java, and it's a great language to start with because you have typing, you have objects, you have interfaces, And
Exactly.
so it's a very, very good language to start programming with. I really like it. I appreciate it. Yeah.
And you have great library design, which is the
Yes.
next big thing. And it's not just someone jerked it out, but it's really good. Yeah, so
Yes.
we're a bit far off the
That-
Z 8-bit computer, but I think, yeah, our love, shared love for compilers and programming languages, all good. So your first goal was to get into the design of 8-bit computers. Then your goal, if I understand it correctly, is to do an ecosystem, which you have
Yes.
now, all the bases, and now you're looking for people who actually live and work in this ecosystem, right?
Yes, exactly. So of course, the first goal is also to make it an educative computer. So this is the goal of making the whole ecosystem, of course. If someone wants to learn about hardware or programming, low-level programming, I think it's a very good entry point, I would say. So let me make the link between what we just talked about, and the 8-bit computers. So today, I think the computers are way too complex. We have so many levels of abstraction, even on MCUs. So I work with MCUs every day, and I still think they are very complex compared to an 8-bit computer. You have CPU pipeline. Sometimes you have caches. You have RAM. You have a cache, maybe cache for RAM. You have L1 cache, L2 cache. So we have so many layers of complexity. It's very hard to have deterministic code. It's very hard to know exactly what will happen with your code, which is not the case with the Z80. With the Z80, you know exactly how many clock cycles this instruction will take. You know exactly what will happen at this moment when you reach this instruction. And I think this is something that I'm really attracted to. And you can write very small code, very compact code that do a lot of things. And for example, the kernel of my operating system, Zeal 8-bit OS, the kernel is like 8 kilobytes, less than 8 kilobytes. And so it was written in assembly, of course, but it shows you the power of an 8-bit computer. And actually, even my JavaScript emulator cannot keep a full speed. Even on my computer, I have a Ryzen CPU, and it's not 100% speed accurate, mainly with the video, if you add video. Even though I optimize the video part, it's not as fast as the real hardware. So it tells you how many layers of abstraction we have today.
Yeah.
I think it's I don't know if it's a PT or I don't know what to think, but I think an 8-bit computer is very good for that. It's like you can make very compact code that will go fast if you write it properly.
Yeah. Yeah, crazy. You can't emulate it on a Windows machine. Okay. Yeah, tell us a bit about the Zeal 8-bit computer. I just built it, so yeah, but I didn't talk much about what it is and why it is and stuff like that. That's your job. So I can show the actual machine, which is in this sweet box here. Oh, okay, yeah, same here.
I also have it here.
So
yeah, we have pretty much the same. So what do you want to know exactly about all the components, or
yeah, why did you do what you did? Yeah, just talk about the components and the general design, and what did you start with and what did you extend then, and maybe a little bit of history of the development of the machine.
If I knew, I would have taken out the old prototypes. I still have all the prototypes.
Okay.
Yeah, anyway, it's okay. So first, of course, the most important is the CPU. So I wanted to use a real Z80 CPU because it was still in production. I mean, yeah, it was still in production when I started the project, and same for the PIO. And so what I wanted is to have a CPU, of course, some RAM, ROM. At first, I used an EEPROM, but then I changed later on, and of course, a PIO for having some GPIOs. At first, if I recall correctly, so at first, the first prototype did not have the MMU part. I used memory banking. So, you know, on the Z80, you have 16 line of addresses. So I used the first 32K for the ROM and the last part for the RAM. That was pretty limited. A lot of people were like, yeah, that's good, but we cannot run CPM because CPM needs RAM everywhere. And other people were like, yeah, this design is very easy. It's very easy to understand, very easy to implement. But then I was thinking about it, and I thought for a long time, for months, and I came up with the MMU thing. So you have your 64 kilobytes of virtual memory from the Z80. You cut it in 4 equal parts, which each is 16K. And this 16K can be mapped to any 4 megabytes of physical memory. So you have 22 bits of addresses of physical, what I like to call physical addresses. And so it means that in the first part, you can map RAM, ROM, video RAM, anything you want. You can map it as you like. So it makes it very extensive. You can run CPM on it. You can run anything you want, basically.
Okay.
So I think this is quite the major strength of the 8-bit computer. I think it's the memory mapping, the MMU. I like to call it MMU, even though there is no protection, but the memory management unit. And of course, there is the video board, but the video board came, I would say, the stable version came much later this year, actually.
Yeah, I saw that. You were using UART to connect to the machine, right? Before.
No, I'm using parallel. It's parallel. So
okay.
Here you have the video connector. So that's why it's in 2 parts. It's because at first I only developed the motherboard, and if anyone wants to implement his own video board, he can with an MCU, with another FPGA, whatever you want. It's possible, and you just connect them, and you have. So of course, all the connector is documented on my website. Okay. And this is a parallel port. So you have the 22 bits of address, you have 8 bits of data, and all the other signals. And so it's a parallel bus. That's why you have so many level shifters here, because the FPGA does not support 5 volts.
Yeah, can you talk a bit about the design while holding the board up and telling us CPU and PIO is left from the CPU,
is
right?
Is it a bit blurry, or is it okay? I don't
know. It's good. It's good.
So this is the PIO. Oh, yeah, it's mirrored. Yeah. So this is the PIO. This is the CPU, the 80 CPU. So both are PLCC packages because I didn't want the board to be too big, so I took these packages.
And PIO was used for the GPIO pins?
The PIO is used for GPIOs, yeah. It's connected to this small port, which I call the user port.
Okay.
And so this generates the UART signal and the I2C signal. But this is done with bit banging. There is no UART chip on the board, actually.
Okay.
So this is the level shifter for the PS2 connector, for the PS2 keyboard. This is the analog parts, I would say, like the analog decoding of the PS2 signal to generate a nice active low signal when a key arrives.
Okay.
Here you have an inverter. Well, this is also used for the PS2 logic decoding. This is LS07, so this is an open drain buffer. This is mainly used for the H blank and V blank signals that come from the FPGA. Since these are 3.3 volts, here they will become 5 volts thanks to an open drain signal.
Okay.
You have the 512 kilobytes of RAM. So 512 is quite big for an 8-bit computer. Here you have the logic glue. This is a PLD, programmable logic device. Here you have the MMU. Those 3 are make the MMU. So you have 2 4x4 register files. So like this makes a 4-byte RAM. This is a 4-byte RAM. This is a buffer to be able to read back the MMU values. And this is the NOR flash. So I wanted to take a NOR flash and not an EEPROM because on the bootloader you can actually flash it. So you can really update the OS directly from the Z80. The Z80 will reflash the NOR flash.
Okay.
And so 10 megahertz crystal oscillator. No, this is not crystal oscillator. The active oscillator, 10 megahertz.
Okay.
And I think I missed some here. Yeah, here you have the RTC and the I2C EEPROM. This is either 32K or 64K depending on your board. And this is I2C, so it's a bit slow, but it's used on the system as disk B by default. It will be mounted as disk B.
Okay. Okay.
So it will be slower than this one, which is a NOR flash, which is accessed in parallel. But I think it's acceptable. Yeah, from my experience, it's acceptable.
Okay.
And of course, here you have the FPGA board with the lattice FPGA. What do we have? This is the op-amp for the sound.
Mhm.
You have here all the power circuit to generate a nice 3.3 volt, 1.8, and 2.5 volt, I think.
Mhm.
And of course, jack. SD card, I still have to write the driver for it, but at least it's here, and there is an SPI bus.
Okay, so there is no SD card reading right now.
The
Was it-
hardware is here.
Yeah,
The
plug
hardware
one
is
in
here.
and sort of, okay. Nothing.
The most important is that the hardware is here.
Yeah,
so
sure.
you
Yeah.
can just write the driver.
Yeah. Okay.
And so this USB port is only for flashing. When I have to flash the FPGAs, I plug it here, but then you don't use it. There is no data actually. And of course the VGA port.
Yeah. Okay.
Here there is a small extension board in case I do some extensions in the future. I don't know, out of the box, like HDMI, for example. If I want to add HDMI, we'll just need to plug it here, and then we have an HDMI output. And that's pretty much it. I mean, the board seems simple. I mean, I don't know if it's because, of course, I designed it, but for me it's simple. But I think there is not that many complex things on it, I guess.
Yeah, but to get it simple, I bet it was more complicated before.
Oh, for sure. I mean, to get this result, it took me 3 years. So,
Yeah,
I mean, yeah, 3 years. So
yeah, so simplicity is a result of complexity in the end.
yeah, you're right. Yeah.
So yeah, very good. Nice. Can you tell a bit about? So you also wrote the BIOS and stuff like that. Can you tell a bit about this and the Zeal 8-bit OS, how you did that, and how communication works if you start the machine? So you switch it on. What happens?
Yeah. So actually, before Zeal 8-bit OS, I wrote a small monitor. So you just type commands, and then you can add commands. You can just interpret the commands. That worked, but then problems started. I mean, problems started when I added the I2C EEPROM, and then you have an issue is that the file system that you have on the EEPROM cannot be the same as the one that you have on a CF card, on a compact flash, or the ROM itself, because it's much smaller. So, for example, let's say that you have FAT16 on a compact flash. FAT16 requires at least 8 megabytes, I think, or I don't recall exactly the minimum. But like on a 64 kilobyte ROM, which file system do you want to put on that? That's not possible. You cannot put like all the file systems that we have today.
Why did you use the I2C?
I2C EEPROM?
Yeah.
Because I wanted a way, I wanted the motherboard to be usable without the video board. If you don't want the video board, you can use the motherboard alone. So if you only have the NOR flash, you couldn't do much because the NOR flash is read-only. I could add a file system on the NOR flash that is read-write, but the blocks on the flash are 4 kilobytes. So it means that every time you want to write a single byte, you will have to erase a whole block of 4 kilobytes. It's getting a bit too technical in this, but yeah, I wanted the board to be usable without the video board.
Okay, I see.
Which will also lead to the creation of the OS. So when I noticed that the monitor would be too complex to use if I have the board like this, because it means that if you want to read a file, you need a file system. But if you have a file system, you have to know whether it's a ROM or the EEPROM, and depending on where the file is, you would need different commands or different functions, which makes it very hard for someone who just want to write, let's say, a high score file for your game.
Sure.
It means that you would need to know where you want to save it and which file system. Makes it very complex. So I came up with the OS ID. I mean the ID with the operating system, where you have a kernel with drivers, which will abstract this complexity. And then you write your own programs in userland, if you want to make the comparison with Linux. Let's keep the bootloader for now. When you power on the board, it will directly jump to the kernel. So you are in the kernel directly. It will initialize the BSS, so it will write 0 to some parts. It will then go through all the drivers and initialize them one after the other. So a driver can initialize the PIO. There is one that will initialize the ROM, the NOR flash, and register it as a disk. and specify which file system it's using. Then you will initialize like the MMU, for example, and any device that you can think of. And after that, it will the kernel will read the init.bin. Like you can specify which file you want to run on startup. By default, it's called init.bin, and it will be loaded from one of the file systems that you registered before. So the kernel only has the notion of file system and disk letter A, B, C, D up to Z.
Okay.
And so it will load the path a/init.bin, for example, and it will ask the driver first the file system, get this file, and the file system will ask the driver, please give me this data, and then it's copied to RAM and it jumps to RAM. So all the programs that you have on the 8-bit OS are executed in RAM directly, not in Flash.
Okay. Oh, okay. So on startup, the CPU jumps to a specific memory address. That's where your bootstrap loader or bootloader sits.
The good thing with the Z80 is that when you power on, it jumps at 0. So it directly goes to 0. So when you power on the 8-bit computer, there is a reset thanks to. So this very small chip that looks like a transistor. It's not a transistor. It's a reset supervisor circuit. It generates a reset signal, and it will initialize. So the reset signal will initialize the MMU, and it will set the first page to 0, physical address 0. And the component that is mapped as physical address 0 is the NOR flash. So which means that the first byte of the NOR flash will be executed when you power on the board.
Okay.
The first 16 kilobytes, of course, because I said that each page is 16 kilobytes. So the first 16 kilobytes will be mapped to the first page when you power on the board.
Okay.
So if you put the kernel there, the kernel will execute.
Okay.
And if bootloader, it will be the bootloader.
So you have kind of a partitioned NOR flash because you have the drive on there and you have the boot ROM.
In theory, I should. In practice, not really. In practice, in the OS, you can configure where the disk image, the read-only file system disk image is. So you just have to specify the physical address.
Okay.
You have raw code, and right near it, right after it, you have an image, disk image.
Okay, and your file system driver basically says from here to here on the NOR flash is a file system.
Exactly. On the ROM, I implemented a very simple file system that is only because it's read-only, so it's very simple. It's not even a file system. I would say it's a file table. It's a file table. Like you have a table with name of the file, date for metadata for the file, file name and address on the offset. Then file name offset. That's very easy. But for the EEPROM, I wrote my own file system, which is called Zeal. And this one, I'm still working on it. Cannot talk too much about it right now, but yeah. So the goal would be to make it usable on bigger memories than just 64 kilobytes, which currently is the limitation. But yeah, this one, so ZLFS looks more like a FAT16 or FAT32. So you have a FAT table and you have some pages, and in a page can be a directory or data for a file.
Okay. Yeah, you explained this much better than I ever could, so I will just use that in the video.
Yeah, no problem.
No problem. So you are the master of your own machine, so that makes total sense. Is there anything that you would do different if you would do it again?
Yes, I think the PS2 keyboard decoder, I would say. So I'm going to show you back. So these are 595 shift registers. So these are 64 series chips. And here you have all the decoding logic, as I said before, to generate a signal. So there is no FIFO. It's only a single byte that is stored. And the active signal only lasts for a few microseconds, depending on some of the values that there is here for the resistors and the capacitor. Since the beginning of the project, I refused to use an MCU, because I think I wouldn't say it's a bit cheating, because some of the retro computers had MCUs. I mean, even the keyboards, the PS2 keyboards had MCUs inside. But I think for this part, I should have used an MCU. I just didn't want the MCU to be more powerful than the Z80, because it didn't make sense, in my opinion. That's just my opinion. Some people would argue that an FPGA is the same as an FPU, but that's another topic. I think for the PS2 keyboard, it would have been better to use an MCU, even a not very powerful one, like, okay, 20 megahertz one, but with only 100 bytes of RAM, or with like a very small ROM, maybe 1K of ROM, it would have been better, I think. Because today we are limited with the keyboard. Some keyboards require you to generate a reset signal when you power them on. Okay. If you don't, they will keep sending data until they receive the signal. With my board, it's not possible to get this signal. So which means that some keyboards may not be happy, not a lot of them. The ones, I mean, all the ones I tested myself, I did not have this issue. And there is another problem, is that it's not bidirectional. With all these logic gates, I could have made it bidirectional, but it would have required much more components. So which means that this is why when you plug your keyboard, the caps lock, the scroll lock, and those LEDs cannot be turned on, because usually it's the computer that tells the keyboard, please power this on.
Ah, okay.
So I think that's my biggest regret, I would say, on the project. But for all the other components, I think I did. I don't really regret. I'm looking at my board. I'm at my board, like I'm looking like which component I regret. But I think all the other are. I don't regret any other choice, I think.
Yeah, it works. So
yeah, exactly. Well. Yeah, I hope so. Yeah, like a few weeks ago, we went to an exhibition in Shanghai to present the project. And it was powered on for I think more than 9 hours without never stopping, and it worked for 9 hours straight. So okay, I consider this is working.
Okay, that's good enough.
Yeah.
Okay. What else do I have? What do you think is the future of Zeal 8-bit? And why is it called Zeal 8-bit? 8-bit I can see, but the Zeal?
Yeah, so I love the animal, a seal. I find them very cute and very funny. So I wanted a board that was associated with an animal, and since I like seals and it's a Z80, so the combination just made it is
okay.
And if you go back, I think to my first video, or on archive.org, you can check my website. Some
historic.
Yeah, exactly. Because the logo, the logo used to be a seal. I don't know.
Okay.
Yeah, maybe I can show it. So the logo used to be a seal. This used to be the logo.
Okay. Yeah. I remember, I think.
So I did not use it a lot afterwards, but I think I will start using it.
Okay.
Some people in the community enjoy it, so
yeah. Good. So what's the future of Zeal 8-bit?
I would say make write all the drivers.
Okay.
Write more drivers. Make the system more usable. Not usable, I would say. More stable. Make the version 1.0, because now it's still in beta. It's still 0.4.
Okay.
Maybe make more extensions. So for example, right now, this week, I just published this extension, which is a ROM, so that you can simply flash it and plug it directly to the board on the extension board. And you can even use it as bootable. So this can replace the NOR flash that is on board. So it's very, very convenient if you want, for example, to port CPM or any other bare metal program, and you don't want to take out the PLCC chip every time, because it's a bit, let's say, tiring to do. This is the extension port where you have all data pins. This is the video board. Video board will always stay. Then you have another extension that I've been working on. Yeah, I cannot talk too much, but so I think you can guess what this does.
Okay.
So yeah, maybe more extensions. And what I would like to do also is work on more programs. I mean, I'm a software guy, so I really like to write programs for it. Emulators, like I started writing a chip 8 emulator on it. or make more videos. I would really love to make more videos. It takes me some time because I mean I did all this project on my spare time because I have a full-time job. So I would love to make more videos on it, but at the same time I still have to support the bootloader, the OS, the text editor, the all the tools that I'm working on. I would like to make maybe something like I've been thinking about making an IDE, I would say, that is like Pico 8, something like where you can write code and then you can also make tiles at the same time, make some sound at the same time, and just execute something. That would be great. That would be awesome, but that takes time.
Maybe write just a transpiler for these. So you could use TIC80 or something and then just take the file and make it run on the...
That's also something I've considered. I mean, there's a lot of things I did. I like to work with a lot of projects at the same time. I've been also working on porting some Game Gear games or Master System games because both of them use the Z80 as the main CPU.
Yeah.
I started writing a compiler that would compile to Z80 code. I started writing a bunch of things. So I would say I would like to keep developing for the board and also adding more features maybe to the FPGA board, FPGA board too. For example, for the sound, adding so the hardware supports 2 channels, right and left. But in the code, I still need to implement this for each voice so that you can program a voice to be on left or right. That's also something that I would like to do. And so I have a lot of ideas, a lot
so
of
much to do, so little time.
Yeah, but mainly, like I think I would like to make more videos, and mainly videos about how to write a demo for the Zeal 8-bit computer, for the video board mainly. How to write a demo, how to use the sprites, how to use the tiles, make some sound. I think that would attract people, and people would be more interested in this.
Yeah, especially I was thinking about writing a game or maybe porting this Border Dash game I did in Pico 8. It would be pretty simple in my mind, but there's the hurdle of getting code on the machine. There's the hurdle of compiling code for the machine. I don't know how to do that.
I see. In C or Z80 assembly? Which one would you prefer?
I think I would go for C.
In that case, so the Zeal 8-bit OS supports C. I wrote a library that for SDCC compiler, which is the main compiler for Z80, I would say today. I wrote some bindings for the syscalls. So you can use IOCTL, open, read, write, close those functions directly in C. There is a header. So then you can use C to generate programs. There is even an example. And then you can run them in the emulator. I think today the emulator is the best thing to use for programming. This is what I use. I always use this for system programming or even my own programs, except if I have to interface it with the SNES controller or anything hardware, hardware specific. And because the emulator that I wrote is cycle accurate. So this is something I wanted really to do because I have UART and I2C, which require cycle accuracy. So the whole emulator is cycle accurate. So you can really single step and see all the registers, the memory values. So it may be better. But if you're writing in C, I don't know if you can see. So the emulator has a disassembler, so it will show you the disassembled code, but it will be assembly, not C. So but yeah, I think it would be the best thing to do.
Yeah, so maybe a good idea would be that we just do another video where I sit on my development machine, we do a Zoom call, and you help me set it up, and others can see how I set it up because I have no idea. We set it up, and then you have your video about how to set it up, and then we can show how to do a few first steps and then get into this.
Yeah, no problem. That would be great. Yeah, of course.
Good.
I would like to see your feedbacks because you already gave me good feedbacks on the PCB. So maybe you will have some feedbacks about how to get the IDE running, the compiler running, how to get it set it up. So
yeah, but really your PCBs are flawless, and a guy like me who well, doesn't have too much knowledge about how the system works and stuff like that could do it without instructions. So that should be doable for everyone, really. And you made an excellent guide. So I found that before, forgot about it, did the build, found it again, and thought, oh, I'm an idiot. But yeah, that's how I roll. You know, in my day job, I've built systems, businesses as systems, and I enjoy not being constrained by systems and instructions when I do my projects. So it's my freedom, so to say, because I have in my day job, my job is to systemize everything in a company and not having that and just rolling free and making errors and just, yeah.
Aren't we all like this, software guys? Like we don't like to read documentation, but we complain that it doesn't work.
Yeah.
We are the same. Yeah, but when I was watching your video and I saw that you did not solder the fuse holder, I was like, you're gonna have a good time afterwards to solder this. Oh, yeah. When I saw that,
it took me 7 minutes or so to solder it, and I just cut it, and yeah, done.
Yeah. Actually, I don't know how you did, because it's very hard when you have the button near it, and you can literally burn it very easily because it's just plastic.
Yeah, I was very, very careful and very slow, and used a lot of flux and stuff to just try to get it in there.
Yeah, it's the only SMD component on the motherboard.
Yeah,
because it was either the huge fuse, which are like 5 centimeters big, and
it's half the board. I mean, if you do it as a first component, it's not a problem. You have room from both sides, and it's not that hard. Huge pads, so it's just if you have components right next to it, it's a little challenging, but
yeah, even for me, it's still challenging.
Yeah.
Well, in China, making PCBs and it's very convenient, you know. Like if there is a bug in my PCB, it's okay. I fix it and I send it to the PCB manufacturer and I receive it in 3 days, 4 days.
Okay,
like, it's very fast.
That's good.
Yeah, and there is no shipping fees. Like shipping fees are like less than €1. It's 50 cents, 40 cents. So I have never bought PCBs on internationally. Like I've since I came to China, I started making PCBs when I was in China. So I've always paid in Chinese yuan. So I don't know what's the prices for you in Europe. I have no idea.
Yeah, we should maybe do a separate episode just about China and how it's to live there and work there and stuff like that. I think that would be interesting.
Yeah, for sure.
If you want to know more about this, leave a comment below and we will do an episode.
Yeah, for sure. So I also put my videos on Bilibili. I don't know if you know, it's a Chinese platform because there is no YouTube. So I put it on Bilibili where there is the Chinese audience.
Okay.
And the audience is completely different from YouTube. It's mostly people, students who are interested in computer science. There's few people who know about it, but because in China in the 80s, there was not that many people having 8-bit computers.
Yeah.
There is not a big community here of retro computing. So the public is very different, but it's very interesting to see that there is a lot of young people who are very interested in low-level programming, and they know about MCUs, for example, but are very intrigued by 8-bit computers.
Okay.
So it's really different audience than YouTube.
Yeah, I think in the 80s and 90s, gaming consoles were banned in China. You couldn't get a gaming console, so I think Nintendo was it. They put a whole console in the controller so that you could use a controller and connect it to the TV, but you couldn't have a physical console to use.
So the one you're talking about is called the IQ. So this is the C64. And actually, I have one.
Oh,
because
cool.
I bought one because you can still find them in China on the second-hand market.
Okay.
I bought one. It's pretty cool. So yeah, but there was no gaming console. I mean, you could game on the PC, on computers. Okay. But they have something that they call so in Chinese it's like 学习机, which means like machine to study. Okay. And actually it's a keyboard which has a cartridge slot to put Famicom games. And you could play Famicom games on it, but officially it's a device to learn. It's a learning device. And so there were some exercises like English exercises or typing exercises, but I think most kids back then used them for playing more than studying.
Okay, cool.
I made a video about one of them. which
Okay.
is called the SP2000. And it's very interesting because they had their own, so it's using a 6502, and they're using, they made their own GUI. So you have like a Windows-like GUI on an 8-bit computer. It's very impressive.
Okay.
And there is floppy disk support. There is a controller support. They wrote some text editors and very good games. Honestly, it's impressive. And actually, you can still find them on the second-hand market in China. Very easy to find them.
How does second-hand market in China work? Is there other shops like these thrift stores in US, or what's there?
You have some, it's not shops. I mean, I've been to one in Shanghai. It's more like, how we say this in garage sales, something like this. So they're on the floor and they put things on the floor, but it's in one place. But the biggest second-hand market is online.
Okay.
Like usual. Yeah, and you can find a lot of things.
Okay.
A lot of Game Boys and things imported from Japan back then or from Hong Kong. So you also have, for example, the Laser 320, I think, the 8-bit computer from VTech.
Yeah.
You have a lot of 8-bit computers, but MSX also, you also have some MSX.
Okay.
So you can find a lot of things.
Great. Should make a video about this.
A lot of things to say about China. It's because when you're living in Europe, you don't really know about China except from TV, I would say.
No.
You don't really learn a lot about Chinese culture, and I think there is a lot of things to learn about.
Thanks for everything, for sending in the machine. I will keep using this, and we will set up a development environment and see how it goes.
Yeah, great. If you have any question, because I saw last time you were struggling like with trying to change the directory.
Yeah, that was all in the guide. I was just ignorant.
Yeah, I mean, there's a lot of things, like even for the bootloader, for example. I don't have time to talk about it, but like the bootloader lets you reflash the board, and you can also reflash the FPGA board. Actually, it can even update the bit stream of the FPGA. There's a lot of things, but yeah, of course, there is a guide for the bootloader. I try to write as much as I can. Try to take all the knowledge I have in my head and try to write them to not only to share them, but to help people with the OS, with the board, with the video board. So I try my best, but it takes a lot of time, and I still do this on my spare time, so not unlimited.
Yeah, and you wrote a lot of stuff. I saw that you have multiple websites with stuff on it. So yeah, great job. And
Thanks.
I'm really impressed with what you did all on your own.
Yeah.
Awesome. And yeah, as I said, if you want to have one of these nice little machines here, you can still buy them. I will again put a link in the description. Thanks to Omar for joining in this interview. It was great.
Thanks. And thanks for your advice. I think it was you during the video with Noel Retrolab for the art of electronics, right?
Yeah, right.
What about it? Actually, it turns out in my company we have open library that there is a lot of books inside, and we can just take them to read them. And there is like the art of electronics, and it actually helped me quite a lot to understand a lot of
great
things. But you have to read this book as a dictionary, not really like.
Yeah, it's crazy. I tried reading it. I have it somewhere here. I actually have both. There's the Art of Electronics. The 3rd edition, I think it's also the final edition. And it's quite a book.
Yeah, this is the one.
I tried to read it, and as you can see, that is my bookmark, and that is front. That's how far I came. I guess
some time. Yeah.
Chapter 3, and then there's a lab book, which has actually, like the things they do in the courses, and they tell you in detail what to do and how this works and problems and solutions and stuff like that. So that is, I think, also a very interesting book.
Okay, I didn't know about this one. I knew about the first one, which is the one I read too. But yeah, I mean, when I'm looking for something, let's say, for example, transistors, BJTs, I just read about it, and then when it gets about like the curves and how to calculate things like that, then it's okay. I already understood. Yeah, exactly. I just switch back. But actually, even this book has interesting things about CPU. I think they also talk about CPU and interfacing with some logic gates and things like that.
Yeah, okay, it could be because it's. I think they started this in the 80s or something. It's not a new book, right? The 1st edition 1980. So yeah, that is even before the C64 and stuff like that. It's right at the 8-bit era.
It's very, very good. I really learned a lot reading it, and I discovered it when I was when you were interviewing Noah Retrolab. You talked about this book, so this is where I learned from.
Yeah, I'm looking forward to his next videos because he just finished his game, World of Goo, I think it is 2.
Yeah,
which was
exactly.
very successful. The first one was very successful, and yeah, I hope he makes videos soon.
Yeah, I hope so. I really enjoy his videos too.
Yeah, me too. Me too. So, as I said, thank you very much for everything, and we will schedule a second or third video then about the Zeal 8-bit computer.
Whenever you want. Yeah, we can do third, fourth, even a series if you want.
As I said, great work, and really enjoyed building the machine, and I'm sure I will also enjoy using it and programming for it. So how huge is the community right now? Do we have an estimate?
I think we are 300 people, but not everyone is always online, of course.
Yeah, sure. Who wrote the Snake game? Did you do the Snake game?
Yeah,
okay.
Yeah, I did. Good. I did write the Snake game. This is the one I presented during the exhibition that we were in 3 weeks ago. It was a demo for because I wrote the video board SDK. Mm-hmm. I wrote it in C, and I wanted to test my functions. So I just wrote the Snake game in C just to use this library.
Okay. Yeah, but this is the best. I mean, it's not a non-visual thing to have an OS and stuff like that, and having a game is a next level. So people understand you can write a game on this. So now it's interesting. Before it's just some stuff where characters run on the screen, but now it's a legitimate 8-bit computer.
Yeah, but it takes someone with a lot of experience like you to understand this, because when we were doing the exhibition, there was a lot of people who are mainly young people or people who don't know about 8-bit computers, and they did not understand what this was. They were like, what this is? Like, it's a computer. And most of them were like, oh, it's a computer. Can you go on Google on it? Can you go on the web? Like, no, not this kind of computer. Oh, okay, so can you play LOL on it? Can you play World of Warcraft? You see, there is still misconception here because there's not a big retro community in China. Let's keep in touch.
See you.
Thanks again to Black Swan for sponsoring this video. If you are a business owner or plan to start a new business, please get in contact. We're happy to help. More infos in the description below.
Thank you for watching Retro is the New Black. If you are new to the channel, please like and subscribe. If you like the video, please share. Every like, share, and comment helps a lot. Until next time, bye-bye.